Hi, this is me again. I'm sorry I forgot one little thing from my in my previous video on the importance of knowing DevOps stuff for programmers, where I explained a little bit about the crawler. I forgot to showcase the one of the elements or surfaces in the crawler. If you see the structure here, I've shown you huh, I've shown you the crawler, the article inspector, the Mongo tweet server, and I also mentioned that we have a service called graph builder that stores the nodes in in a database called Neo4J. Now I'm going to show you that the that database. We'll see what nodes we have there, what kind of things we can do with those nodes and those links. So without further ado, so let's go to the web. It has a web UI for you to experiment with the queries, right? It's here. You go to the get the IP of the container, then 7474. There you go. You see we have nodes of different types. These are the types of node that you have. A node can be tagged or labeled with more than one type. For example, tweet a retweet is actually, of course, also tweet, right? A reply is also tweet, code is also tweet, you know. And these are the kind of links that we have in our graph, that we define in our graph. So if we want to have a quick look of the nodes that we have and their relationship, just do this simple query. You see, this is an example of query in a query language called Cypher, which is very intuitive actually, because it's almost graphical. Here, yeah, just by visual. Well, I'm not going to delve into the type of social media analysis that we can do. I'm also still learning about that, but I'll just do some simple Cypher queries to show you some possibilities, right? So here, okay, let's display some more nodes. 25, it's just too few. Let's see. We can display in this web browser and in this application only 300 nodes. So let's do that. What is this? There are lots of user account that doesn't have any, that is not connected to any tweet, which is uh wow. That's strange. Anyway, let's see some. Just by looking at this, you can see some interesting, maybe interesting pattern. This one is probably is more interesting because you have different types of nodes here interconnected. And let's start with this one. What does this tell us? Well, so there's a tweet that is retweeted by a lot of people. Why? Probably because this guy is popular, or maybe the tweet itself is interesting. Okay, Okay, probably here there's no interesting message because my keyword is just some sterile keywords, right? Like taco. I mean, yeah, whatever. Taco, Cancun, YOLO. Would be interesting if you do some queries over some hot topics or maybe politicians, political parties, stuffs like that. So you can see some pattern here, some pattern of relationship between nodes. So the reason why we have this Neo4J in our um, system, well, because it really offers us. You see, we have the tweets as well in Mongo and also in SQL Server, but you know, um, doing queries for data that is naturally is a graph in SQL is just it gets unwieldy very quickly. It's just so difficult. And here in a Neo4j with its cipher query, it's very easy. For example, let's say I want to know a tweet. What do I want to know? Let's match. I want to know two tweets that share the same keyword. Okay, that's a simple example. So the relation would be like this. Give me a second. I forgot. Okay, this is an example. We tweet one has keyword keyword type keyword, and then this keyword is also mentioned by another tweet. Okay, we're not interested in the link itself. We're just interested in the nodes. Tweet 2, tweet return, or you can put T1 K T2, right? Okay. It's gonna take a while. Why? Do I have that many nodes? What grows quickly? I have not that much. How many nodes do I have? Match, return, count. I have like 21,000 nodes so far. Probably I need to limit it to make it limit 50 maybe. Yeah, well, it's a little better. Oh yeah, finally it no, not this one. It hasn't returned yet. Okay, without limit. Okay, so let's see here. So this thing YOLO. Oh, so these guys, all these tweets, these blue ones has the same hashtag, right? So what can we do with this information? Probably if we assume, if we assume in our use case, or in our model, that people who share the same keyword in their tweet probably is related somehow, then you can conclude that what the wait that the person that tweet that post this tweet is related to the person that post this tweet, and then you can apply some kind of graph algorithm over the that derive links between people, so you can find maybe triads, click, I don't know what else, clustering, stuffs like that, right? So that was the wait. So what the hell? I'll just close this tab. What? Okay. I think it's trying to display so many nodes. No. What's the IP again? That one. I hope my previous query gets stored. Oh no, it's not stored. I have to type it again. But anyway, that's just one simple example of of a cipher query. As you can see, it's very visual. You see, this shows the direction of a. If you don't care about, let's say, if you don't care about the type of the nodes, you can just leave it out like this. But if you do care about the type, you can specify like this. And if you care about the node itself, and you want to see that in the result set, you can specify a variable, right? Like this. So in this case, you can see that sorry, article. You can see that this tweet, these are the tweets that contains article. That's basically what it is, right? That contains article. Why is it okay? These two tweets contain the same article, but this tweet is also a retweet of this one. Why? Why would they do that? ¿Qué pendejada este tweet? ¿Qué tiene de suerte eso? Okay, first this guy posts a tweet. No. What is this? Oh, this. Oh, I think there's a bug here. I treat this in some cases. Okay, because you can in a tweet you can copy paste maybe a URL in my current analyzer. I don't check if it's a real article, like from news site or from the Twitter site. If it's from the Twitter site, like this one, maybe I should have treated this one as a tweet node instead of article. So yeah, that's a little bug here. So let's find one that is not a bug. So these are relationship between articles and tweets. Okay, this is more interesting. This retweet is a quote of this tweet is a quote of this tweet. This tweet, it contains this article, and this yeah, I don't know. Well, we have to be creative with our analysis, right? I'm still learning as well. But the point here is the query is very, it's pretty much similar to SQL with some syntactic sugar maybe. So you can basically draw the graph that you want to extract from your database in your query, right? This is very cool. Of course, you can see it in a tabular form as well. So this is useful maybe when you want to do some ETL, extract transform load to another um, database, or you want to do some heavyweight analysis. Maybe if you, for example, if you don't specify the limit, then probably maybe you can get a stream of result set, and of course you don't want to process those result set at once in the memory. You probably want to offload that processing to things like Spark, maybe in micro batches. So yeah, probably um, that's one thing to get around this the amount of data that we have in our graph database, right? In fact, you can. Oh, cool. So there's a Spark module for the Cipher query for Neo4J. How does it work? So basically, this will uh, best transform the result set into, how do they call that? Spark RDD. Uh, yeah, distributed data set. I don't know how it works, but the point is, if these queries are simple, and if you want big data processing, then probably you'll have to do some more configuration over your Neo4j so that you can integrate or offload the processing to your Spark cluster, right? That's the idea. What else? Well, so yeah, that's all. It's free, but in the free version of Neo4j, you can only have one database in a single instance of the server. That kinds of limit the kind of the things that you can do, because normally you want, like as I mentioned before, you want to do some query that extracts and then some processing over the, no, wait, you do some query and you get the the relationship between tweet, the person, the tweet, the keyword, and another tweet and another person, and you want to make a link between those two persons and apply analysis over the relationship between those persons. So first you need to do a query over the original graph, this one, and then the result of that query and that pre-processing will have to be stored as another graph database. In this time it's a person to person graph, right? And then over that second database you apply your graph algorithms. But with this free version of Neo4j, it's you cannot do that in one single server. So probably you will have to create several instances for of your of Neo4j. So you will need at least one instance for each derived database, graph database that you want to have. Of course, it can quickly become a administration nightmare, right? So then At that point, maybe you can decide to buy the license of this database. Um, what else? I think that's all for now. uh, I'm still playing around with this, and it's very. I'm just trying to. I think part of uh, being a data scientist or analyst is, first you need to get familiarized with the data that you're dealing with. So you just need to look at it maybe and stare at your data, and so you understand the the form, the texture of your data before you can start thinking about, okay, what kind of things I can extract from this thing, from this data. So I'm at that stage at this moment, staring at my screen. All right. So that's all, folks. See you later. Bye.